Hello students, today's agenda is to check your homework. You will be simplifying expressions and you will be working on 10.1. Today students will be able to combine polynomials with quadratic exponents and compare them to integers. Okay, so if we have something like this, okay, that's a huge expression. What can we do to make it a little bit more simpler? And so we start looking at the ones that have the same variables raised to the same power. Okay, so maybe I should start by writing that. Like terms are terms that have the same variable raised to the same power. And when that happens, then we can say that we can combine like terms. Combine like terms, okay? Meaning putting them together. And so in here, we can see that we have a constant. Because it has no variable, we say it's x to the 0, or you can just think of a number that doesn't change. The -3 also doesn't have a variable, so that would be considered a constant number. Then we have positive 4x, negative 2x, and negative 2x. And we can see if you don't have different colors, you can also do different shapes. I'm going to do a combination of both right now so that you can see, but if you just have colors, you can just put different colors. That's fine. So I'll use a triangle in here in case you don't have different colors. So this has a square, so that will combine with this term. Notice how, and I'm making my shapes funny, because I'm including the sign. That's very important, the sign on the left, okay? And so I start combining. It's better if you combine the ones with the bigger exponent, which is called the degree. And so if I have 5x squared minus x squared, then that will give me 4x squared. The variable and the exponent stay the same, okay? For my x, I have 4x minus 2x, that will be 2x, minus 2x, that's 0x, so I don't need to put it. And then for my constant, I have 1, but then I owe 3, so 1 minus 3 is -2. So that will be my answer for this first example. Okay. If I have x squared plus 2x squared plus 3x squared minus 6x plus 9, again, we are going to combine like terms. And so I'm going to start. For this one, I'm not going to use different shapes. I'm just going to use the different colors. So I have x squared, I have 2x squared, and I have 3x squared. All of those are like terms because they have the same variable, same power. Okay? And I also have, whoops, I'm using the same one. I have negative 6x, but then there's nothing that has an x only. And finally, hopefully these are not too similar, I have positive 9. So as you can see, the only ones that we're going to be combining is the x squared. So when there is no coefficient there, that means that it's 1x squared. So 1 plus 2 is 3, plus 3 is 6x squared. Since we don't have anything to combine with these ones, we're just going to bring them down. Notice how we are writing these in descending order. First, the exponent that is bigger, then the next that follows, and then finally the one that doesn't have a variable. Okay? Okay, in this case, let me put this in parentheses. In this case, usually when we have parentheses, the first one stays the same way. So 5x squared plus 3x. And the second one, we're supposed to multiply the plus. Some people get confused, and so they prefer to put a 1 in there. The plus 1 times each of the terms inside of the parentheses, and in reality, because it's a positive, it's not going to change anything. And you know what? I just noticed that I put the parentheses again. The reason to bring them down is because we want to get rid of those parentheses. Okay, some people get confused with them. So, okay, we just bring down the terms inside, and then we start multiplying. Positive 1 times 8x squared, it just stays as positive 8x squared. Positive 1 times negative 5x is the same, negative 5x. Okay, again, when we have a plus in the middle of two parentheses, it doesn't change anything. Okay, it stays the same. And then we proceed to combine like terms. So we have the 5x squared in here, the 8x squared in there, and then we have 3x and a negative 5x. Okay, so when we combine them, 5 plus 8 is 13x squared, and 3 plus negative 5x is negative 2x. Okay, notice how when we combine like terms, we're just looking at the coefficient as if it is an integer. We have a positive 3, we have a negative 5. Since they have different signs, we subtract and leave the sign of the bigger one. Okay, so that's why it's negative 2x. That's what it refers when it says to compare them to integers, that you're working in similar way with the like terms as when you're putting together the integers. Okay. We have inside of parentheses 3x squared plus 2x minus 5 minus 5x squared minus 3x plus 8. Again, when we have parentheses, some people prefer to put a 1 in there so that they don't get confused, and multiply. In this case, because it's a negative outside of the parentheses, it will affect every single term. If it was a plus, nothing changes in here. When it's a negative, it changes all the signs on these terms. It changes the signs in here. So the first one stays the same because there is no sign outside, so it's just 3x squared plus 2x minus 5. And then negative 1 times 5x squared is negative 5x squared. Negative 1 times negative 3x is positive 3x. Notice how it changed in here, and it changed in here. So what do you think is going to happen for the last one? Negative 1 times positive 8. Negative times positive is negative 8. It changed in here. So anytime you have a minus outside of a parenthesis, in reality, all it does is change the sign, changes the sign, and changes the sign. Okay? We're now going to combine like terms. Notice how I'm including the sign to the left. Okay, these two have x, and these have no variable. Okay, so we combine them and we get 3. Notice how I'm working with the coefficients only. 3 minus 5, negative 2x squared. We subtract and leave the sign of the bigger one. 2 plus 3, 5x. Negative 5 plus negative 8, negative 13. And in here is because when you have the same sign, you add and keep the greatest sign. Okay, so that's going to be my answer. Some people say, why don't we combine these two? Because they don't have the same power. Okay. In this case, we're going to do, and this is also called distributive property, okay? I'm just gonna start writing in this one, distributive property. Just like in here, it was distributive property. Okay, distributive property. So we start, and in here it was only negative, so you put a 1, in here is a negative 3, okay? But it's the same process, you multiply all of them. The rest you're just gonna bring the same way. So you have 5x plus x squared, and then we start negative 3 times x squared, it's gonna be negative 3x squared. Negative 3 times 2x, negative 6x. Negative 3 times 1, negative 3. And then we can combine. The second step is combine like terms. Okay, so 2 steps in here. And just like before as well. Okay, so we have the x squares. Okay, and we have the x variables, and we only have one constant. So I have 1x, remember that if there is no coefficient, there is 1. So 1x squared and negative 3x squared, negative 2x squared. 5x and negative 6x, negative, some people would say negative 1x, that will be correct, but traditionally it's written without the coefficient of 1, and then you just bring down the negative 3. Okay, let's make this last one more interesting. Again, the same steps. First, distributive property. So, but notice that this 5 is just going to go with the terms inside of this parentheses. And the x is going to go or multiply the terms inside of this second parenthesis. So, 5 times x squared, 5x squared. 5 times x, 5x. For the second one, we say positive x times 2x, positive 2x squared. Positive x times 5, positive 5x. Don't forget the x in here. Some people tend to just bring down the 5 and forget the x. Now we're going to combine like terms. And we have the x squared and the other term with x squared. And we have this term with x and this term with x. We combine them, and so 5x squared plus 2x squared, 7x squared, 5x plus 5x, 10x. Okay, and so that's my answer. So now you're ready to do 10.1 and have fun.